Good evening to one and all. In the previous lecture series, we had discussed about the different components of thermal power plant. Some of them are precipitators, electronic precipitator, boilers, different types of boilers, draughts, different types of draughts, stokers, mechanical stokers, ash handling system, etc. Now we are going to discuss about the major important part in the thermal power plant, that is the steam turbine. Turbine. What is turbine? Turbine is the rotary mechanical device that extracts energy from the fast moving flow of water or steam or gas or air or other fluid and converts into a useful work. Next, we will discuss about the working principle of turbine. The working principle is very simple. When the fluid strikes the blade of the turbine, the blades are displaced, which produces the rotational energy. That means the blade moves or rotates. Here the working principle is very simple. When the fluid strikes the blades of the turbine, the blades are displaced, which produces the rotational energy. Simple. When the fluids or air or steam strikes the turbine blade rotates and it converted into a rotational energy. And the turbine shaft is directly coupled to the electric generator. Mechanical energy is converted into a electrical energy. This electrical power is known as the hydroelectric power. Here we are going to discuss about different types of turbines. Some of them are water turbine, steam turbine, gas turbine, wind turbine. First, steam turbine. Steam turbine is the prime mover in which heat and pressure energy of steam is transferred into a kinetic energy and later in it transformed into mechanical energy of rotation of turbine shaft. This is the image of the steam turbine. This is the rotating blade. This is the stationary blade. The power in the steam turbine is obtained by the rate of change in momentum of the high velocity jet of steam impinging on the curved blade which is free to rotate. The steam from the boiler is expanded in the nozzle resulting in the emission of high velocity jet. This jet of steam impinges on the moving vanes or plate mounted on the shaft. Here it undergoes a change of direction of motion which gives rise to change in momentum and therefore a force is created. Steam turbines are mostly axial flow types. The steam flows over the blades in the direction parallel to the axis of the wheel. This is the steam entry, a turbine, the turbine which is connected to the generator. While the high velocity steam strikes the turbine blade rotates. As the turbine is coupled with the motor, that means generator. Next we will discuss about the principle of action. Impulse turbine. Pressure energy of steam is converted into the kinetic energy. Impulse action of high velocity jet of steam due to change in its direction is used to rotate the turbine shaft. Next the reaction turbine. Reaction force due to expansion of high pressure steam when it passes through a set of moving and fixed blades is used to rotate the turbine shaft. Due to expansion of steam, pressure drop occurs continuously over both fixed and moving blades. This pressure difference exerts a thrust on the blade. The resulting reaction force imparts rotatory motion. Impulse turbine. Parts are casing, nozzle, turbine blade. In nozzle, pressure energy of steam is converted into kinetic energy. This is the nozzle. Turbine blade. This is the blade. It converts kinetic energy into mechanical work. Then rotor and shaft. High pressure steam from boiler is supplied to the fixed nozzle. Here nozzle pressure falls from boiler pressure to condenser pressure. It leads to reduction in pressure. Therefore, it increases the velocity. High velocity steam impinges on moving curved vane. It leads to changes in momentum. Pressure remains constant when steam flows through the blades. Next one is the reaction turbine. This is the casing fixed blade performs the function of the nozzle in impulse turbine. It directs the steam to adjacent moving blade, the shaft rotor. In case of reaction turbine, high pressure steam directly supplied to the turbine blades without nozzle. Here the steam expands as it flows through fixed and moving blade. Continuous drop of pressure takes place. Velocity of steam is increased when it passes through the fixed blades. It produces reaction on blades. Therefore, the propulsive force causing rotation of blade is the reaction force. Hence, It is called as the reaction turbine. Next class we will discuss about the difference between impulse turbine and reaction turbine. Thank you.